Bismillahirrahmanirrahim. Okay guys, so we continue with example number 2. Uncontrolled half-wave rectifier with R load, with the resistive load. Okay, now we have a circuit which is supplying resistive load. The AC source here is supplying the resistive load through a diode. So please bear in mind that diode is our uncontrolled device, uncontrolled power switch device. Okay, we have later, you have to recognize all the devices that we going to use in our power electronics. So we have diode, simple device with two terminals like this. Okay, then we shall have a thyristor later with another terminals to control the gating, the switch on and off of the device. Okay, and then later we shall have a MOSFET, and MOSFET or IGBT with also three terminals: input, output, and gating. Okay, this one gated by current source, this one gated or controlled by voltage source. Okay, so we have in every circuit of a commutator, we shall have a source, we shall have a load, and we shall have a device or the converter itself. Okay, so you have to understand in terms of the basic requirement of the circuit. So this is the three components involved in every of the circuit for our converter. Okay, another one is that when given in terms of their parameters or data inside the circuit, so we have to take note, because when we simulate data in our simulation, it will present different kind of parameters. Now, given here in terms of RMS, okay, it's a RMS value. And later, if you simulate, it will show you in peak. So this is peak, not RMS. And voltage peak, current also the peak value. So you have to take note. So once you get the circuit, the question, you just jot down. Okay, jot down the information into the circuit. 240 volt peak, sorry, 240 volt RMS, and we have a 5 ohm load. Okay, then we have a, this one is 50 hertz, 5 ohm. That's for the timing. Okay, some more we have here the source. This is the instantaneous voltage source of the system. So first thing you have to do is that you have to rewrite, even though you are requested or not, you have to rewrite the expression. So rewrite the voltage expression. So actually Vs is equal to Vmax sine omega t. So omega is 2 pi f, and so means that you have to put here Vs is equal to, this is Vrms, so 240 volt times 2 sine 2 pi 50 t. So this is the expression of our voltage here. So you have to write, even if it's requested or not. So for the current situation, you have to write. 240 times 2, how much you get? So for the provided slide, you can pause a bit for calculation, and you can continue after that, such that you can understand our discussion. So 340 sine 100 pi t. So you can write the current instantaneous source voltage like this. Okay, then only you go with the question. Okay, then only you control with the question. So you resketch the circuit, and note on the holes of the components. So the source supplying the circuit in the clockwise rotation. So the current flows from positive to the device in this manner. So you have a positive pulse on the source, as well as here positive. The source is coming to the load, so here is positive. So the KVL will take place within this arrow direction, clockwise direction. Okay, so require us to calculate the first thing, which is our average. Sorry, the request to sketch the output and the output. So the first output is our sketch the waveform for the circuit output of 2 cycles, voltage waveform for 2 cycles. So it means that you have to sketch comparing between input and output. Yeah, between input and output. So you have to sketch between input and output. So you make it in one plane, which is one of it is your V in, another one is your V out. So for 2 cycles means that it should be 2 pi here, so 4 pi here. 2 cycles. Okay. So one cycle you should have start from 0 maximum, then return to 0. Then also on the next cycle you start and repeat to the 0. Okay, draw nicely. With this input from your source, so this is your V in, what you expect to have on the, or you can see from the load point of view. So usually we shall have only positive cycle, which is rectified. Negative cycle you will hold. Positive cycle it will pass through, negative cycle it will hold. So this is the 2 cycles output of this system. So this is V in, this is V out, and V in and V out. At the first stage, if you just sketch, so you can just note on the maximum peak or the available information that we have here. You don't have to key in yet whatever that you have not calculated yet. Okay, we just request to sketch, so you just sketch. We want to see how you understand or you comprehend the circuit behavior. Okay, then next, number 2, B. B is what are the average load current. Average load current, which is I naught, which is equal to V average divided by R average. But V average we have not obtained yet, and given here only RMS voltage, and what? the resistive value. Here 15 ohm and the incoming of 240 volts. So what you have to do is that you have to use the available information that given into the formula. Okay, we have V average over R, which is required to calculate for average load current, but we have only V peak and V peak. So from the formula we have know that V average is equal to Vm over pi, was stated in the previous page. So we just include here I naught equal to Vm over pi divided by R. So we shall have Vm already here, 340 divided by pi divided by 15. So you will have, sorry, the resistor is not 15 but it is 5. So it was 5 actually, not 15. So you have to do that again. So V max, which is 340 divided by pi divided by 5, not 15. So we shall have values of 21.6 ampere. This is our average load current. Average load current. So 5 ohm of load delivered by 140 volt sources through diode. Uncontrolled rectifier, we have shall have a 221.6 amp of our load current. Then we need to calculate what again else? The average, sorry, the absorbed power the load. So P load. So you can see here P load, the resistive element. So P we can calculate by I square R, or V square over R, or VI. So all are RMS, and RMS. No? Okay, but we have here only average. This is average, average values. So we can use formula of which is given before in terms of average or peak. We have peak here, we have average here. So P can be used. We can use the previous formula of half wave rectifier here, average output power, which is Vm squared over 4R. Vm squared over 4R. So we have here Vmax squared over 4R. Vmax squared over 4R. So Vmax we have here 340 volt squared divided by 4 times 5. So we shall have a value of 5760 watt. This is the absorbed power. Then we need to calculate the power factor. It is the power factor. How much the power factor of the half wave rectifier? By right, we already know that the average, the generic power factor of the rectifier is 0.71. but you have to prove it